Yo, what's up, everybody? Welcome back. Today we are working on our neural network training. We are on day 2 of this thing. Last stream we implemented, a very, very basic gradient descent and back propagation. So we did we took the simplest neural network we could think of, where you take in, two numbers, A and B, right? It's like this. And we connected them to a single output neuron who tried to learn which of these things is bigger, right? So this was supposed to return 1.0 if A is bigger and 0.0 if B is bigger. We did this by creating like a network of mathematical operations. So it actually looks kind of more like, actually, I think we can print the network if we type here, print net loss, I think. Hold on. I think we can show it. Nope, so close. This is, oh. Hold on, it's broken. But, okay, it's broken because I changed the API the other day. But it's like essentially something like you take, some weight and multiply it by the input. Then, so this is like a multiplication. So this points back to like weight and A. These come together with like a multiply operation. And then, this gets added to, weight 2 times B. So this guys kind of like multiply like this, and then these guys get summed. And like we can build up this like graph of like things that we went through to get to the final answer. So we like throw this through an activation, and then we like compute like the loss of this thing. And all of these things are differentiable. So if we want to like find out how do we make this number smaller, we just kind of like walk backwards through this chain of operations and say, when we get back to W, like how much did this affect the final output? How much did this affect the final output? And we can like kind of nudge everything in the right direction. Don't forget the bias. Yeah, not important. Not important. It's in there, but like in order, like in terms of like explaining, it's not important. And so like kind of like tracking everything this way as like individual floating points is like kind of silly, right? This ends up being like a really, like for this network, it's fine, right? But as we get into larger networks where the final goal of this thing will be to implement like a barcode scanner, we would need to, I think it would be better to kind of track these in batches, right? So we should be able to say something more like, here is a bunch of weights for some layer. Weights, right? And like we go through a operation that applies these weights to like a set of numbers, right? And so as we kind of try to improve our API, I think that we should try to find a way to kind of fit this together with with something that can run on the GPU. Because as we start doing more and more complicated things, we're going to be wanting to do more at once, and like training on the GPU will be great. So today, I want to experiment with just running the existing network we have with OpenCL, maybe doing back propagation with OpenCL as well. And through like learning how OpenCL works, we can find like a good API that will work for both GPU and CPU running. That's kind of like hand wavy where I want to go. And so yeah, we did a little bit of research in the past couple hours of like, how the fuck do you just run code on GPU? And like we looked at like OpenGL compute shaders, Vulkan, OpenCL. OpenCL seems like the most promising option in terms of like a, like compromise between control of like pipelining of GPU stuff as well as like flexibility of how to run that stuff. OpenCL feels kind of right. Vulkan was very verbose and like really verbose in the goal of getting maximum flexibility for like rendering stuff. We're not doing any rendering. OpenGL didn't really feel like the right tool. OpenCL, we got to the point where we can like run an example and it feels okay. So yeah, the plan is let's try to do like anything in OpenCL, just like sum to arrays or something, or like element wise, number by number sum them or multiply them. And once we have that, we can try to do like matrix multiplication, maybe is like a good second step. And then trying to like hook that up to our training framework would be step number 3. Maybe just doing the forwards pass, but maybe doing backprop as well. Maybe. We'll see. We'll see. If it becomes too much of a pain, then we will give up and reduce scope of what we want to get done today. But here we go. Do anything in OpenCL. So we were Googling OpenCL examples. Did I lose my browser? OpenCL examples. And it wasn't one of these. The big fox linked us something else. He said the first one you get on Google. Yusuf, thank you for the prime. And I think we have this cloned and running. OpenCL examples. And they have like some things in here, but like square array seems like somewhere we can start. So here he did something. We don't actually, I don't, you know, we don't know what he did, but he did something. If we look at this example, and we say, what the fuck is going on here? He includes, well, they're kind of hidden away, but he creates some OpenCL device, which I think is defined in here. So he says, like, OpenCL, could you list me, like, what platforms you have? This is very, like, OpenGL-y, right? When we do EGL here, when we've worked with EGL and OpenGL and all that stuff, you see something similar where you say, like, hey, give me a list of, like, you know, NVIDIA, AMD, CPU, Intel. Like, that's kind of my memory. Is that what this stuff usually is? Then we say, hey, like, hey, for this platform, what devices do I have? So, like, I might have, like, 3 AMD GPUs just, like, plugged into my motherboard. So this will let me enumerate those. Oh, sorry, Derp Days. I missed your prime earlier. If you're still here, thank you very much. And so here he, like, picks a device, I guess, is what's going on here. Yeah, he returns the device here. So then he goes and he creates some sort of context. We can assume that that's like initialize OpenCL stuff for this GPU. And then he builds a program, which, what does this guy do? This is very analogous to OpenGL shader compilation that we've seen in the past, right? He's like, create me a program with some source code, build that motherfucker, and if it's wrong, then we have to like log some stuff about it, blah, blah, blah. The programs here are pretty different than what we've seen before in like OpenGL shaders. So here is his program that squares 2 arrays of numbers together. It looks very much like C, right? He says, give me, I have a couple inputs, right? A array of floating point inputs and an array of floating point outputs. They're annotated with this like global macro, and the function is annotated with a kernel. So I think kernel is kind of like the name in this land of I want to run this thing on many things, right? It's like functions that run on many things. My understanding. Okay, let's also keep in mind I learned about OpenCL like half an hour ago, so my representation in my head of what these things are is probably wrong, right? But we'll get there. Initial bench is going to be slower than CPU for sure. GPU is only worth it for big batches, but we can kind of do our forwards pass on like a million numbers at once or something, right? Or like a million's too many, but we can do it on like a lot of numbers at once to prove that it's faster. I think that'll be fine. Okay. So he says, I've got an array of inputs that I can access any of the elements in that array, it looks like, is my assumption. And then he says, get global ID seems to be some sort of like OpenCL built-in to say like, hey, we're going to call this function one time per input. And maybe I'll want to look around me, right, to do like convolutions or like do adjacency, multiplication, whatever. But like hand wavy, I should probably be looking at the element in here that is related to me, and then I just square it by sticking in the output, right? Now, it's funny that these things can go out of bounds. It's because there are these things called like work groups, if I understand correctly. The GPU like multi-processing architecture is kind of fucking weird. Like because you're doing, they don't want to have like one processor for like every single computation that they're doing. So they kind of like group computations together and like run them in lockstep, if I understand correctly. So probably what's happening here is, you know, you're going to have some threads that are running this code that like don't actually need, like that don't like do the right thing. Sorry, that like are like out of bounds, right? They've like instantiated some of these that aren't that don't match like array size or something like that. I have to look into this more, but we're really going off vibes right now. So he makes a program, he creates some buffers for the inputs and outputs, and he copies that shit from CPU somewhere. He pulls that kernel out of that program, right? So this square function or that square kernel, is one of many kernels that could be in this program. Well, I guess in this scenario there's only one, but the API supports there being many. I guess, right? Is the assumption we can make here. Then he says, yo, here are inputs and outputs. Then what's he doing here? He's getting the workgroup size. Then he queues the work, I guess, and waits for it to finish and reads the output back. Oh, and here we could actually log the output and then we could see something interesting. So that's pretty big. Pretty big. Can we reduce this and let's do like 1,000 and new line in here. Yeah, there we go. There's a bunch of numbers that are growing in size. So here we see like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay, cool. So we have an example that does something. So I guess we should try to mimic this example in some way, shape, or form to do something on our side, right? We've seen someone else run some code, but I think that we need to use that somewhere, probably. Which window is in the right environment here? CL info. Okay. Let's say, I guess we need to link link OpenCL to our program, right? I guess. So, link library OpenCL. I guess this is the first step. What is he complaining about? Link system library. My bad. Okay, I guess we are not in the right environment. So we had a Nix shell that we figured out the right things in here. OpenCL headers, these guys. All three of these guys are what we wanted. What are we in? We're in our smelly repo. And we just kind of slap these guys in here. Okay. Exit. I'm like 100 shells deep. All right, let's try this again. Let's try it again. What font to use? I don't know. It's probably either hack or like the default one. One of those two. Shellception, hell yeah. Okay, so this guy can link OpenCL now, and I guess it looked like our entry point there. I guess here, let's like initialize like a, I don't know, OpenCL executor or something, right? We can probably assume that we're going to be doing operations on here. And let's do like an init here. And figure out what's going on here. Okay, we'll ignore all the existing neural network training we're doing. And just say OpenCL executor init. Okay. And what goes in here? We can do this. This is like C import. And in here we do a C include of CL to H. I believe this is the way to get started. And then here we're going like CL, what was it? Platform info or something? get platforms or something was the first call. We're gonna have to look again. We're gonna have to look again. Yeah, get platform IDs. I think there was an OpenCL cheat sheet somewhere as well, which we can use to kind of get a better feel. Here we go. So we can probably assume that we kind of just go through this shit in order, right? But we will see. Okay. So this guy, he takes in a platform. Oh, he takes in, sorry, num entries, platforms, and num platforms as an output. So we can probably assume here that this is the length of this guy. We should probably just look up the fucking function, right? So he takes in number of entries that can be added to platforms. Then he takes in the output array, and this is how many things will go into that thing. Cool. So I guess we do 1 seems reasonable. So kind of following what we saw here before, we can do like this thing has to be a CL platform like this. And I guess we say if this guy is less than 0, I assume I wouldn't mark those constant. True. So return CL success if the function is executed and this is supported. There are non-zero number of platforms available. Otherwise, it returns one of the following errors. Okay, cool. So this is on return, I guess. So I guess we should probably have like CL, CL error or something. And here, this is going to maybe return something like this. And this is going to come from whatever the return type of this guy is, I guess, which is a CL int, I think. Yeah. Right, so like this, and we go like switch ret, and if it's CL success, then we're chilling. Else return error, unknown error, and then we can start hucking in these guys. So they have these. Platform not found. We got this. Invalid value. And then we got this. Out of memory. Okay. So this seems kind of reasonable to me. Kind of do this. Whole goal is whole network in a kernel or something more like less. I don't know. The goal is GPU execution. So probably I'll probably have like a few kernels for like, applying different layers. I'll probably have like a kernel to do convolutions, a kernel to do back propagation on a matrix multiply, like all of those things. And then maybe we'll find later that it would make more sense to kind of like combine operations. But for now, we'll see. We will see. Okay. I think I assume this won't compile right now. Oh, C import failed is interesting. Oh, because we need to link against libc, sure. True, so true, dude. You're making a Zig tensor library? Probably, but maybe more specific than that. Platform needs to be variable here. Okay, that's interesting. Do we need like a CLX or something? Yeah. Probably. There we go. Okay. Cool. So let's print the platform ID, I guess. Platform is this. I don't know if this number does anything for us, but what the fuck is this? Oh, this is a like opaque structure. Interesting. So can we do anything with this platform? Where's our cheat sheet? Get platform info. So we can like get the name in here. Let's do that. Let's do that. So given our platform now, we should be able to, we have like platform name is, let's say, like 100 U8s. So we have the name here. Oh, this is param name, my bad. What is our options here? The info must be like an enum. We must be able to query like different pieces, right? So param name, we might want to do like platform vendor, maybe. Okay, and this guy is going into output. So like 100, platform name, and null, probably. So this should return AMD if we've done this right. Yeah, nice. Nice, okay. So we are on our AMD card. Hello, huge, huge. We are here. Okay, so then once we are on this platform, we want to like extract a device from it. So get device IDs for this guy. Can we just fucking do one? Is that what they did in the square example? Probably, right? Yeah, they just yoink one out of this guy. Sure. Seems reasonable. I'm down for that as well. We just take whichever one it wants to give us. And we probably need to be a little careful about making sure that we're mapping all the errors that we might hit. Right? So like in here, we have invalid platform. We have this guy already there and already here. Okay. Cool. Cool, 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 cool. So CL get devices now. Or to get device IDs, I guess. Okay, so what's going in here? We got platform. We got device type. So we want GPU. Okay. Well, yeah. Num entry is 1, and devices returns a list of these guys. So this is like device ID. And null here. And then here we can go device ID is CL device ID. Nice, huge. Huge, huge, here, huge. And then we can ask for some device info, probably, right? Let's just try to prove that, we have something in here. Oh, we probably also want to make sure that CL get device IDs. We want to make sure that our errors are mapped here. Invalid platform, invalid device type. We got invalid value, which we already have. We got device not found. We got this. Out of resources, and we got this one, which already is there. Okay. Seeing GeoHot write TinyGrad is so confusing. It seems like he has no idea code or read instructions, but like presumably he does. Dude, is that not how you feel watching me? Reading instructions is not my strong suit. You just kind of huck stuff at the wall and see what happens. Okay, so let's try to get some info out of this guy. So can we get the device type here or something? Or like maybe something more interesting. How many compute units do we have? Get device info from the device ID. We got, what else goes into this thing? The param names, that's this. We got the parameter value size, so I guess this thing's supposed to be like an int output? uint. Compute units is CL uint. Undefined, so we put compute units here. And then I assume, like, what are the param value size here? So this is like 4, probably, I assume. Yeah. And then null here. And then we should be able to be like, GPU has this many compute units. Okay. Okay. There we go. Okay, so we got a platform. We got a platform. AMD. We got a device that has 20 compute units. Hype. Hype, 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 hype. Which means that we got our devices. Cool. So, what does this guy do after that? He creates a command queue. So this is buffer management, memory management. Oh, we need to create a context, of course. We have to create a context, of course. Which we forgot. Here. Okay. What is this guy doing? Is this based on any article? Probably not. Just like YOLO, you know? Just huck stuff at the wall, see what works, see what doesn't. Chat helped a lot here. I started with trying to do Vulkan, and then that looked like a shit show. Then I looked at OpenCL compute shaders. The big fox pushed us a little bit into doing like OpenCL land, and then I think maybe RC Arnston did as well. I don't remember. But I think OpenCL is probably the right fit for what we're trying to do here for now. I don't know. Fuck it. Okay. So, this is like we say, give me a bunch of properties and their corresponding values. Sure. So this is like very EGL style, like parameter value, parameter value, parameter value in an array. And I assume that these are like things that we want out of our context. Yeah. So probably we can just not give a fuck, right? I assume that that's what this guy does. Yeah, he's just like, create me a context, I don't give a fuck. I also am down to not give a fuck. Oh, interesting. So this thing returns. So how does that work? Valid non-zero context and error code return is set to CL success. Ah. So I see. So this returns error code as an output. I see. Was it int probably? And then we are probably like break block like context is CL create context. What's my GPU? It should be a Radeon 6700 XT. Should be. So we're like, I don't give a fuck. What is the number of devices? 1, and then we give him the device that we had. Then we have a notify function. What the fuck does that do? Callback function that can be registered by the application, and he will tell us stuff if we care. We don't care. Null, user data for the context function, null, and red. Okay, and then try CL error red. Okay, break block with the context. Hype. So this context, presumably we have to do something with it. I assume that the context will be used like everywhere else, right? So like when we create memory objects that we're going to put data on, this is attached to this OpenCL context. So I assume that the context is a thing that we want to kind of store here, which is probably like a CL, what the fuck is this thing? CL context. Right, something like this. Something like this, which means that we probably have like D in it as well, right? And presumably, hopefully this guy that we're copying, he just has CL release context. Nice. Don't have to free like platform IDs or anything. Seems reasonable to me. Okay. How's that looking for us? Type of I32 ignored, so we can just say, please go fuck yourself. I don't care. Error union is ignored. Whoa, my bad. All right, let's go, baby. Let's go. Okay, so presumably we now need to like, let's say that we for now just want to add like a bunch of numbers to a bunch of other numbers, right? So we're gonna say like A's B. Well, maybe it's more like as we are executing things, we're probably gonna like chain together many operations, right? So like we're probably gonna be like, I'm gonna add like GPU buff 1 to GPU buff 2 is probably how this is gonna end up looking, right? I don't know. Right? And so like having some way to like represent that stuff seems kind of reasonable, right? That seems reasonable, and this guy's almost certainly going to have like initialize with data, right? And a D in it that like frees that data, probably, right? Surely. I don't fucking know, man. And so we're probably gonna have like some of these CLMEMs sitting around, right? Probably. And this guy's probably gonna have to use some context. Maybe this is made from the executor, right? So like make buffer, returns a buffer, and this takes in self as an OpenCL executor, and he creates a buffer through this API, right? That seems reasonable. So this like creates some stuff with some flags, and then how does he like upload data to the buffer? Here, right? So he's gonna like enqueue write buffer onto some command queue with something. So maybe like maybe this is part of some executor or something. What does our like example program do? He does some program stuff. We'll ignore that for now, right? So this is gonna like compile the kernel. I think that looking at like getting the data before that makes sense. Here is where he does it. So he has create buffer with some like flags of like read only and write only. Those are probably like hints to the GPU of where to place this stuff. And then he enqueues a write. Yeah, okay. Cool. So like, let me think for a second. I guess creating the buffer and putting data in it are like different steps. I think that's what this means, which is fine, right? And then he has like, does he have like release buffer? Release mem object. Yeah, he does have that. Okay, so I think that makes sense. So like our buffers are in our program, I guess, don't take any data, right? We just kind of do this. And we probably have like hints here. Like read only, write only, right? Right, that's kind of what this guy was hinting at down here. And this is just hint. Okay. So we use our context. We say to CL, probably uint. Probably. Something like this. CL mem read only. Okay. Write goes to write. And read write must read write. Yeah, nice. Easy. Easy. Which means that here we have like hint to CL like this. Oh, this is actually to CL mem flags. Interesting. Okay. Cool. Size here. I guess we do need the size here. That makes sense. And host pointer. Oh, interesting. What the fuck is that used for? CL create buffer. Is a pointer to the buffer data that may already be allocated by the application. The size of the buffer that host pointer points to must be greater than or equal to the size in bytes. What does that mean? What does that mean? Does that mean that like it will automatically copy that stuff, or does that mean that it will use that as a backing buffer? Because like I assume that this is supposed to be going to like GPU memory. They use null here, which makes sense, right? Because we kind of want this stuff to live on GPU probably. I would like more information here. Ah, I see. If this is called with this in the flags, then the contents of memory pointed to by host pointer at the time of call this create the call define the initial contents of the buffer object. I see. So we don't have to use that, but we could. We could. Yeah, I think it's better to not do that. I don't see. My gut says fuck it. you know? You know? Okay, we need var ret here is cl int. And then this thing can fail with this is the I don't know, buff or something, and then we say try cl error ret here and return buff is buff, whatever. Maybe this should be called, yeah, that's fine. That's fine. So what are our error cases here? We have, okay. Invalid context is should be surprisingly not there. We got invalid property. Property, like this. We got invalid device. That's surely up here already. Really? Oh, surprising. Okay, we got invalid value. Surely that one, though. Invalid value here. We got invalid buffer size. Okay, like this. Invalid host pointer. This shouldn't come up, but whatever. And then invalid operation. Uh-huh. Can we do this? Just, that one's also out of memory. Out of resources already exists, and out of host memory already exists. Okay, cool. Cool. This buffer does not have any data in him, but he does live on the GPU, which is kind of hype for us. So we should be able to be like, make me a buffer of, 1,000 elements. And let's make another buffer of 1,000 elements. And we're going to try to add these together, right? So we're going to be like executor add a b after we say, like write buffer a, CPU A and B with CPU B, right? Something like this. Now, the question we need to ask ourselves is, do we want multiple queues, or do we just want to have kind of like one global queue? I think one global queue will probably be good enough. So kind of just living there kind of makes sense, I think. Yeah, fuck it. And then we probably have to do like this. And we are going to forget this, right? Because like if we have to free every individual buffer, we're gonna fuck ourselves. So we can kind of use like our typical pattern that we've been using, everywhere else, where we have like pools of buffers, right? Where you can have like buffer pool here. And this is just going to be like a, buffers is going to be a runtime segmented list, because we don't really know how many there are going to be, of these, I think. Yeah, and then we can have like a buffer pool here that lives in this guy, and we can call like alloc like create here. I think that makes more sense. And then we don't have to worry about freeing these guys individually. We can just say like, reset. Now, in reality, we might have like many pools that kind of have like different lifetime scopes. So having this as part of the OpenCL executor doesn't make sense. He should be able to like create pools, I think. I think that makes more sense for us. So we'll also say that he has some like CPU allocator that he lives on, probably, and look at this. Init here, and I think this takes like many parameters, so we'll say like typical size and max size here. And we just, this thing like is our structure that's like arena friendly, growable list. Elements live in memory, kind of like in a stable location. And as it creates like a linked list of contiguous memory chunks. So typical size is like the initial allocation size, and then max size is like, this thing could be like mega big, but it just means that like we will only grow up to that size. Yeah, cool. So this thing I think has to be tried, and then this guy also is going to need like a context to allocate from, right? So this pool is going to be like, context is like this, and then this like make buffer kind of goes on the pool now. Yeah. It's kind of more like this. Cool. And so here we go, like, for each element in the pool. For each element in the pool, we do something. We free it, probably, right? So we call cl release memory or something object here with elem. And then we say buffers, you know, is there like shrink to size 0? Nice. Nice. Everyone typing exclamation Discord, there's just like a link in the Twitch description. If you just like scroll down a little bit, it should be on the right side. Okay. What am I fucking doing? So now this guy has no D in it. Fuck you. It's always attached to a pool, which is cool for us. And here we just need to make sure that like as we create these things, we add them to the pool. So I guess if this fails for whatever reason, we need to call release memory object. And then say buffers append buff. Cool. Cool. Okay, so now we should be able to be like, make buffer pool. Give it using our allocator. These guys will live here, and you know, what's our like typical size is like 10, max like a million, like 10,000, whatever. It doesn't matter. Doesn't matter. Okay, so then we have buff pool create a read only buffer of this and another read only buffer like this. And now we need to populate the data, right? Are we missing something here? Context is self-context here. Okay. How fucking broken are we? Sure. All right. What are we looking at now? Pool does not exist. What the fuck? What is it called then? Buffers. Yeah, fine, I guess. If you say so. He did that a while to try to cheat and no T connections. I actually never finished that one. I do want to do that one still, but I haven't done it yet. I think it is funny to. I do want to train a neural network to cheat at connections. That's true because that game sucks. You know. This thing needs to be mutable, which means that like when we use him, he needs to be variable like this. And then I guess yeah, it's fine. Value of I32 ignored. Yeah, true. Oh my god. Okay. Buffer pool is not returning. Why? Who's mad there? Yeah, because this thing doesn't fucking return. I don't know what the fuck I'm smoking. Crack, I guess? Okay, so that builds. And so now we have 2 buffers. There's no data in them, but we can fix that. So now we can be like executor, you know, what is it called? Like write buffer. So we're gonna write A with data. So can we use our random number generator? No, let's do this. We'll use defined stuff. So we're gonna make like 1,000 F32s for a CPU, 0 onwards, we have out I, and we set out to I, right? It float from int on I. Okay, and then for B, we're just gonna do the same, but do I plus 4 or something, right? Or maybe I times 2. Yeah, let's do that. So we'll do like 1 times 1 plus 2 times 4 plus 3 times 6 plus 4 times 8. Yeah. Okay. That makes sense. That makes sense. And so we say, yo, write this shit. And write this shit. Okay. Seems reasonable. So this is a buffer, and this is the content. Which I guess is a bunch of floating point numbers. But, like, theoretically could be anything, I guess. Like, there's no reason that it has to be floating point, right? So maybe this should be, like, just a U8 slice. Right? Because, like, how, like, the way that the data is interpreted is probably defined by the kernel. Right? I got 25 minutes left before my meeting. Love this shit. Hell yeah. Thanks, man. Cancel the meeting. Yeah. Yeah. Just tell them that you're busy watching Twitch. It's an easy fix. Okay, so how does he upload data here? He calls CL in queue write buffer, but he goes on a queue, which this seems to think is deprecated. So can we look at like who this is supposed to be replaced by? Deprecated by version 2.0. Okay, but like with what do I do now? See also this shit. Okay, but like hello, like Jesus Christ. CL create command queue deprecated. It's even common to transfer data to smaller type and expand the kernel. That makes sense. Like we should be like if we have the data as U sizes on CPU, like it's not crazy for us to put them as U sizes or U8s or whatever. Yeah, you like doing smaller makes sense because you want to kind of like touch less memory, I guess. And replaced with this. Oh, I see. Okay. It's crazy that this doesn't like say here, but whatever. Am I fucking high? Oh. I don't know how I spelled that wrong last time. Oh, this is missing. Okay. Okay. I'm assuming that we have OpenCL 2.0. If we don't, like, fuck me, I guess. So I think that we're just gonna have one big ass queue that we use for everything. That's kind of my current plan. And then maybe we like pull out the context somewhere else and we can maybe make more. Maybe this will like turn into, like this can be split later. It's fine. So what does this thing fucking return? CL command Q. Hello, there we go. And so down here, when we initialize this guy, we do this. I assume that this guy has the error code ret in there. We can probably just do this. We can probably have, like, error. CL error out kind of lives here for anybody to use. And then this gets, like, kind of cleaner like this. Boom, right? Boom, boom, boom. And then we can do this, which takes in what? Our context. We have our device ID like this. We got our properties, fuck you. And error code ret is CL error out, and then we try CL error out. So self-documented comes with a 5,000 page reference manual. Hell yeah. Okay, so then we have like a queue that we can do stuff on, right? So we should be able to call that function that they were calling to like write the data out here in queue write buffer. Okay, and I guess we need an output as well, huh? We do probably want an output as well. Okay, A, B, out. Oh. Out buff. So that we don't shadow this stuff. Okay! Whoa. Why is this giving me the wrong fucking function? Oh, because the name is called read, but it says both. I see. So we say, which queue are we doing this on? So we put this shit on our queue. We have our buffer. Okay. We got our blocking right. Probably false, right? I guess, this should come in here because, I assume that this is like the data might go out of scope, right? And so like we need to know if this data will live for long enough. You know what I mean? If this data lives like forever or will run out. See below. So the read command is blocking. This does not return until the data has been read and copied to the memory. That makes sense, right? Because you might want to make sure that like this data will go away at some point. And if it's like we have to manage that, right? So blocking CL is if blocking else false like this. Okay, cool. Offset. Whoa. 0. 0 offset. Size in bytes of data being read or written. So content len here. We have pointer. Here is just going to be content pointer. Okay. And num events in waitlist. Whoa. Specify events that need to complete before this particular command can be executed. Oh, sure. So we're like, hey, don't like do this until all this other stuff has happened. So null here for us, probably. Or if event wait, then this particular command does not wait. If event list is null, then this must be 0. Okay. Cool. And then the event returns an event object that identifies the read-write command can be used, query, or queue await for this command to complete. If the event is null or the in-queue is unsuccessful, no event will be created, and therefore it will not be possible to query the result. Okay, so I guess, like, really the right answer here is for this blocking to always be false. And we should return the event, right? That's kind of makes more sense. Right? That makes more sense. Does this thing, like, return? Probably, yeah. Like this. Okay, so this thing can fail, which means that we get this, like this, and we need to, like, construct our event type. So which I assume is like this, right? Just like a CL event. And then here, we should be able to, like, probably, I guess, how do we wait on these? Where's our cheat sheet? Kernel and event object. So presumably there's, like, wait for events in this event list, right? So I guess it's more like the executor is in charge of this thing. So, okay, var event is CL event. And then we return event equal event like this. And then we have like wait on event, I assume. And this calls like wait for events one event, right? That seems reasonable to me. And this thing can return, so I assume that this guy return like can error out. Yeah. Okay. Oh, and interestingly, oopsie, what the fuck did I just do? Interestingly, this thing doesn't require an execute or anything. So this can actually be run on the event itself. And then, like, does this thing have to be freed? Or what? Like, we have, like, create user event. I don't see anything that talks about, like, freeing events. So these are probably, like, just get some IDs that are, like, allocated by the context or something. Release? Oh, yeah. Good eye. Yeah, good eye, good eye. Which means, how do we want to manage that, right? Because I will forget. Like, I don't want to have to remember to deinit this thing or leak memory. So it would be nice if, I mean, we just do the same thing, right? Where we say, like, we have, like, an event pool that has, you know, events as a stud event. You know, a bunch of these guys, which have events in them. Yep. Okay, which is gonna do something like this. Bop. Random band, end of the night, it's coming down. Okay. End of the night, it's going down. Okay, and then, like, push. That's fine. Okay, so then we have, like, a append event. Cool. So now our write buffer, we need, like, a I guess we just do, like, OpenCL executor, event pool, init. Yeah, something like this. Something like this. Like typical size, max size. This seems reasonable. After all this work, you better not always just dot wait for each write. I will. Don't you worry. Don't you worry. Wait, he could bring in this epoll impl? Yeah. Events is something. Init with alloc. This is like the initial allocator, the expansion allocator, typical size, and max size. Okay. Okay, and then here we pass in the event pool here. Okay, and then, you know, easy. Easy! Okay. So this guy's mad because we need to do like a pointer cast here, I think. Probably like stood mem, slice as bytes is what this guy wants. Okay. I guess really what we should be doing is more like this. A upload, B upload, and then we do like A upload, wait after, and B upload, wait on this. Yeah. Okay. And then we could probably even like choose to ignore this event pool, and we can say like yeah. Event pointer. You know, you could do like if event pool event else null, right? Okay, and then we say if event pool p here like this, and then we can choose to ignore events if we want without having to put them on the pool. Yep. Right, because like later what's going to happen is we're going to discard a bunch of these, right? And then just wait for the final result. I think. If you focus too hard on what he's doing, you can't follow it. You just have to do the mental equivalent of unfocusing your eyes to truly watch. Don't forget to add the errors. Yeah, I'm kind of down to just ignore that problem for now. To be honest. Okay, so we got some buffers full of shit, maybe, if this compiles. Probably doesn't. What's happening here? So, expect to type bool. Why? Oh, sure. Sure, that's true. This guy's pissed off because this thing can fail, I guess? Which means that these guys need to write try. Uh-huh. Okay, that compiles, which is good. And we do get some invalid values on write buffer. So that's interesting. So can we look at this? Invalid value if region being read or written by this is out of bounds, or if pointer is a null value. Okay, interesting. So how is that possible, right? Because these things are 1,000. Oh, this needs to be 4,000 actually, because there are 1,000 floating point 32s, which are 4 bytes wide. Nice. Nice! Let's fucking go! Are you gonna try to use the tensor cores for the map mul? I don't know what that means! So who fucking knows? I don't! I'm gonna try typing the first thing I think of into the kernel. Don't you need to create the event before passing it in? I assume that it makes it. Event returns an event object that identifies this thing. If event is null, no event will be created. Yeah, I think that this is different than like creating user events. I think. Right? I think that like you create user events and then trigger them manually. Maybe? Yeah, like CL set user event status, but I think that this is created by like the OpenCL environment and returned to us if the pointer is non-null. So I think that we're good. I think. But who fucking knows? Who fucking knows? Okay, so we have some data on the GPU theoretically. We haven't really verified that the data is correct, but like we think that there's data on there. Um, and so looking at our example, we should be able to create a kernel, attach some data to that kernel, and then fucking run that shit, right? So how the fuck do we do that? I think that we saw that this stuff comes from a program. So ignore all the parts where they're loading this from a file. This is really the interesting part. CL create program with source. So the question that we need to like ask ourselves is who is responsible for these OpenCL kernels? I think that probably like it would be nice if our executor had like add. You know what I mean? And like he is kind of responsible for compiling a bunch of kernels on initialization. Maybe we'll do, and like maybe later we add support for custom kernels. But like for now, maybe I think that this guy is going to be passed into our like neural network shit, and then we're gonna call like add on the executor. That's kind of like the way I feel right now, but like who fucking knows, right? Who fucking knows? Because like this buffer API is like very like I don't know if this fits nicely, so fuck it. Okay. Let's just do whatever makes sense for us now and then figure out the rest later. Okay. So create program with source, create program with binary, create program with built-in kernels. What does retain mean? What does this mean? I've actually not seen this before. Oh, I see. Sure. So if you're doing like you're passing this thing around to multiple threads or multiple contexts, you need some sort of like reference counting. Probably not multiple threads, but you're trying to reference count this thing, so that's what that's for. Just that like release will only actually free when the count gets to 0, but we're not doing that, so it's fine. Where's our cheat sheet? Here. So it's probably this. Create program with source. Surely. Let's close a bunch of these tabs. We don't need them all. Okay, so I see. So this is like OpenGL style where you can like create a program out of like concatenating multiple strings together. Like analogous like includes. So we're just gonna do one, probably. One big ass string. So I guess yeah, fuck it. For now we'll just be like create program. I guess. Which I assume holds one of these like programs. And then like can we have our like programs here or something? I don't think it makes sense for us to have like a program pool like we do buffer pools. Like it's not like I think these things are just gonna like live forever. And in reality, like really forever, right? So like just fucking don't free it. Like you know, for now, maybe fix me leakies is fine because we are okay with these living forever on God. And we call create program with source. One source. So this is gonna come from like the source. I need to go back and watch the barcode VODs. I didn't expect machine learning. Well, you know, you don't have to. It's kind of a. It was kind of an abrupt jump. Like, can we just do like this? Source len like this? I think we can. And then red. I wonder how this happened. I just got mad one day. In reality, it's just kind of like a funny. It's just kind of funny, I guess is the answer. But I also think it is like a good application. Maybe. Okay, here we go. Is this still for barcode scanning? Yeah. Yeah, eventually. Eventually. Okay, so then once we have a program, we want to like extract a kernel from it, right? That's what they did in their example. So they have like create kernel from this program. And it looks like these kernels are like maybe short-lived. I'm not really sure because it looks like the kernel is like one run of a function from the program, right? Like we see them doing shit like like binding data to the kernel, right? So like here they call like CL set kernel arg, which seems surprising to me because I would think that like, what if you wanted to run like this kernel like 10 times in a row? Like, should we be creating 10 of the same kernel because we're attaching different data to it? Or should we be like, is this kind of like OpenGL style where like it's like kind of like context data that will be associated with the next queue? I assume it's the first. I assume it's the first that we need to create multiple kernels if we are running it multiple times with different data. I guess I'm more interested in like this. Um, memory object will be created with context. Blah 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 blah. This seems like an idiot question, to be honest. In OpenCL, if I have, we don't trust his output, but if it lines up with our guess, then we do because we're degenerates. If I have a kernel in a program and I want to run it 10 times with different sets of data, can I queue one instance of a kernel 10 times, or do I want 10 kernels with different data bound to it? Before each in queue. So this guy's claiming, and so is the big fox in chat. You guys are both claiming that like this is kind of like context bound data that will get reset later, or maybe it's like when you enqueue it, it turns it into something else. Um. Okay. I mean, I trust you guys. Sure. So then, like, okay, fine. So we're gonna have like the same problem here, um, where this is gonna return a kernel that we have like leakies. Should probably put these somewhere, but for now, we'll just make one per kernel and let it live forever on God. Okay. You may need to swap buffers. Makes sense. Makes sense. Okay, so here we create the program, here we create the kernel. So we say, CL, create kernel. What does he want? He wants our program. Okay. Cool. And the name, so name pointer, and it looks like this guy must be null terminated, because otherwise, how does he know when it ends? And ret here, var ret is a cl int, and we go try cl error ret and return kernel. All right. Cool. Simple. Okay, so now we just need to write a program. Now we need to make the program. So can we call it like OpenCL program? And I don't know how to fucking do this yet. How do you do like import file here? I don't remember how to do this. Zig embed file as embed file. Oh, is it just embed file? Yeah. Okay. Let's copy what they do. So kind of ignore. Whoa, do we fuck up this copy? Hello? Okay, here we go. So we have, add. And we have two global floating point inputs. And we look at our global ID. And if we want to, should be A's and global float star B's, I assume. And we're going to do like A's plus B's. Add these two motherfuckers together. I guess, right? I think that's what we want to do. And so now we should have a kernel that we can call somehow. I don't know, man. Let's figure it out. Right? It's kind of just like this, right? And then we need to like execute this kernel somehow. So how do they attach this shit? So they say set kernel args. Okay, so I guess we're going to like expose that as a thing on here, right? So on kernel, we're gonna like set arg with like, what are our options here? We should look up this function, I guess. What does this fucking thing do? Kernel, arg index, arg size, arg value. Whoa. So this is a pointer to us. Oh, how do they know? Like, what the fuck? How do they know the type of the data? Arg size value must be. Oh my god, that's crazy. What in the fuck? This is an insane API. So they're just like fucking huck a pointer at this thing and we'll like guess what type it might be based off the size that you give us. And then we'll probably do some like, they might have like some like magic value in the struct that they can check for like different types, like kind of like runtime dispatch C style. You know what I mean? Likely for OpenCL to know which function you're calling when you're dispatching a work job for OpenCL by marking it as a kernel. It can enumerate for all kernel functions and pick whatever matches what you're calling. Looking for OpenCL to know which function you're calling when you're dispatching a work job for OpenCL. By making it as a kernel, it can enumerate for all kernel functions and pick... Isn't there one function per kernel? Am I fucking stupid? Like, isn't... Kernel equals program, functions, program equal program, sorta. Yeah, okay, I could buy that. Okay, this is an insane API, but I guess we'll say set buffarg, I think is the way I want to do this. So this is going to be like index, use size, like this. And maybe it's like set arg with like arg type here. Right, we could do it like this. Where we have like buff as a buffer. And we could have like a... I guess our other option right now is like uint. I guess, right? This is our inputs and outputs right now? Right? And then we like switch, we say like, we can do it from here, size is I don't know, man. We're getting somewhere. We're getting somewhere. So if it's a buff, we return size of like this, and if it's a uint, like this, and then we have the pointer, which is like kind of like this, I guess. And if it's like is it like this? Something like this? I don't know, man. Then here we can be like, you know, ret is cl set kernel arg with index, which is probably actually should be like u32 or something. Or maybe to be more correct, like cl uint, I assume. Yeah. And then arg size and arg pointer. Yeah. You know, something like this? Maybe? And then how are we must like self kernel here. Okay, so then when we are using this thing, we can call like kernel set arg, which he doesn't like because create kernel here probably is more what we're supposed to do here. So it's like 0 is buff is a upload. Okay. 1 is B upload, and 2 is the number, right? So, and then we must have like, no, this is not A upload. This is A, B. The output argument is going to be out buff, and the third argument is the size. Right? Something like this? You know, something like this. Something like this? Okay. He's mad because CL int is like this. Source pointer expected a double const. Why does he want mutable pointer? Fuck you, pointercast. You can't make me. Constcast? Expected. Okay. This guy is probably mad that this guy doesn't return an error. True. This guy is mad because I guess this has to be const pointers here. If I'm returning references, it does still need to be taken by pointer though, I think. No field name buffer. What do they call it? Buff. Expected any opaque found pointer to this thing. So do I do like a pointer cast here? Is that what he wants? Does anyone know how to help with YouTube? Like, most streams go up there, but like, sometimes they don't. More than half, less than all streams show up. Yeah, something like that. This one will show up there. Like the rest of the relevant part of this will go up there, and it will go up there like tonight. Okay, that compiles. That compiles. Who knows if it's right, but it compiles. So now can we We just have to like run the kernel now, right? So how the fuck does that work? So here he like queues ND ranged kernel. So can we like, oh, and here he's using that local and global size thing. Okay, that's interesting. So, and then before he does that is he gets the work group size. Okay, what the fuck is going on here? What the fuck is going on here? So he says, give me the work group size, which we should learn what this thing says. So, this provides a mechanism for the application to query the maximum workgroup size that can be used to execute the kernel on a specific device given by device. The OpenCL implementation uses the resource requirements of the kernel to determine what this workgroup size should be. This value may vary from one kernel to another. Okay. So, okay. But like, what is it? I still don't know if I fully understand. To map our problem to the underlying hardware, we must specify a local and global integer size. The local size defines the number of work items in a work group. On an NVIDIA GPU, this is equivalent to the number of threads in a thread block. Okay, which is different than a grid. So if I remember correctly, it was like GPU, grid, thread block, thread. Where thread is like one thing in parallel, right? And so then the thread block, so this is like one number. Thread block was like guys that execute together. So like all like 32 threads will go in parallel to do one thing, to do like the same code. You know, they'll like run the same program or something like that. And then like the grid was like, if your thread groups are too small, you can kind of like do stuff in a grid, but like less kind of coordination can happen in a grid or something. And then you have like many grids in a GPU, something like that. So here we're asking, okay, so here they say, give me a global size and a local size, where local size is the number of stuff in that, the number of threads, right? The number of things that can be done together. And then here they are figuring out how many. I see. So the global size is like a round up of how. Okay, they're doing how many elements. This is like how many groups. How many groups need to run to like process the whole array, and then they're like rounding this up to be a multiple of size of a work group, right? Something like that. And then they enqueue this kernel to say, here is how much stuff you'll be doing, and here is the work group size for that thing. Okay, that makes sense. Nothing crazy. Like, that seems like kind of reasonable. That seems kind of reasonable. So let's check this function to like double check that this is true. Global work items. The total number of work items is computed as global work size 0 times ... times global work size work dimension -1 if the device. Oh my god. So this is like, this works for multiple dimensions. So for now, we can just think of this as one, I think. I don't really want to think about like processing 3D arrays this way. I kind of want to just view everything as like a flat buffer for now. And then the rest of this kind of makes sense. So yeah. Yeah, okay, I can kind of get behind this. So we can kind of maybe have a function here that's like run with some context, right? Or it's the other way around. It's like executor runs the kernel. I guess it's probably more reasonable. Yeah. And so this is going to run. He is going to like get the work group size. I think that makes sense. Please do it in integer arithmetic or I won't be able to sleep. Yeah, that's fair. This addition is very integer. It is very integer. I agree. Oh, you're talking about this? Yeah, what the fuck is he doing here? This is crazy. Yeah, that's crazy. I agree. I agree. Okay. Oh, interesting. So we haven't held our device, but I guess we kind of have to. I think it's ID, right? And then when we initialize this thing, we just say device device ID. Uh-huh. Okay, so now we should be able to be like self.device with this guy. Let's get the work group size. This is local size is a CLU int, probably. We should probably check this. Size T, actually. So we'll do this. This is size of local size. This is local size, and then what's the last thing here? Yeah, no, I'm down. I'm down. If it's not that, then like it'll error out, and that's fine. We don't need to specify. Okay, cool. So now we have the local size, and we can say global size is num like num times or something. Num elms or something, right? So we have like rounded size is num elms over local size. Is that how you do this? Okay, hold on. So we are trying to do, it's like num elms plus num elms percent local size or something. So if this is like, if we have, 7 elements that we're trying to run for, and the work group size is 4, we want this to be 8, right? So we have like a few cases here. It's like 4 and 4, 7 and 4. I guess those are the only ones, right? So, or like 8 and 4, where it does line up already and it doesn't. So 7% 4 is 3, so then we need to add 1 in this case, right? So it's like local size minus all of this, right? But now in the case where it is 4 already, then this is going to be like local size minus this. So I think it's like minus is it like this? Is this the integer math you do here? So then you like modulo local size again to get it to be 0 if it's 4? I think that's right. Local size, we could check this, right? We could do like a seal, like round up like a to, like a num multiple. And this should be really more like a give me the type that these things are and use that for all 3. And then it's like num plus multiple num. I think. So this is like round up, you know, four should return 4. Round up 7 to 4 should return 8. And 8 to 4 should return 8. And then I think we need to do like okay. And then we should also try std testing expect false to make sure that this is actually running. Okay, so then comment this out for a second. Oh my god, let me run my test, please. Oh my god. Okay, we need to fucking have our imports working correctly, which means that we have to do like test exe is b add executable or add test. Boom. His name is test. He's got his root source file is bpath source main. Okay, and then we say like add a run artifact of this test exe, and can we just like install this for now? Then we can do zig build and then run the test ourselves. The end project called Smelly. Yeah, it's Spheriforia's ML library. Smelly. And then can we just like do this? All right. It's mad because fine. If our tests use U32s, then it fixes the problem. And I don't have to fix the code. We do need to return it. Okay, so it looks like that's doing what we want. Okay, so now we can go in here and we can say round up num elms to local size, right? Okay, type. And then we call that function. Hello, oh, I need to, these are different Vim instances, I forgot. Okay. This is kernel here. This, okay, what are our parameters here? Work dimension 1, because I don't want to think about it. Work offset null also seems reasonable for now. Global work size is a pointer to global size. True. So this actually has to be probably CL uint here. Okay. Local size is already chilling. Num events in waitlist. 0 and null seems reasonable, and then we pass in an event if we want, right? So here we have event pool. If you want to wait for this, you sure fucking can. So here we say var event pointer is if event pool is not equal to null, we have event else null. And this is going to be a pointer to a event. Yep. Cool. Uh, and then this guy gets the event pointer. Then we say if we have event pool, we pass pointer dot events append of the event. Cool. And then this guy returns the event, I assume. Okay, so now we should be able to run this event or wait for this event. So we should be able to be like kernel execute. Oh, it's executor execute kernel. So this we do care about. And we're executing this kernel with 1,000 numbers to work on, I think. Okay. Local size is use size, actually, interestingly. What does this guy want? Oh, use sizes, actually. It's kind of surprising. Surprising. Okay. He is mad that we run out of host memory, which is crazy, on create kernel. How is that possible? That doesn't seem right. If there is a failure to allocate resources required by OpenCL implementation on the host. Like, this is happening so fucking early, no? Like, this is happening, like, right here. Like, before we've actually put any data on it. So it seems crazy to me that this is failing to allocate. Yeah, that seems insane. I guess it could be if, like, if I throw in, like, just garbage name here, it returns the same shit. Right? Which seems a little sus. So it could also be if we've done something fucking wrong here. How do we know if this compiled successfully? You would think that CL create program with source would return a failure if it was bad. Right? You'd think. Right, so can we intentionally put some compilers in here? Okay, so this, yeah, interestingly, this thing does not flag when we do something like brain dead fucking stupid in the kernel itself. So that's weird, right? That's very strange to me. I would think that this should notice that. Which makes me think that this is like doing the wrong thing. Okay. So can we look at what these guys do when they try to compile their program? They call create program with source. And they just say, "Oh, we don't call build, huh?" What the fuck does this thing actually do? Num devices. Whoa. Program XP was built for all devices associated with the program, sure. Oh, sure, yeah. So just fuck it. Device ID, fuck it. Options, fuck it. Callback, yeah, okay. I can get behind that. I guess kind of like this makes more sense. I assume this returns, yeah. There we go. Okay, now we have unknown error on program build. That's hype. Okay, now can we go back into our kernel and try to make it valid? So global float star A, global float star B, global float star out. Int. Okay. So I assume that we're gonna get the same problem now. Oh no! Is the stream lagging just me? Yeah, it does seem to be bad. Oh no, dropping frames like crazy. Yeah, we're dropping frames. Ugh. OpenCL got him. No, I think it's network. It looks like we might be back though. We back? Boom, 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 boom. Let me know if we're back. I think we should be. I think we should be back. It looks good. Okay. There's no way this is breaking the transcode or something, right? I don't think so. But I will run this a few times and check. No, I don't think so. It's fine now. Okay, good. Okay. Okay, so we should do what they do and do like try to like retrieve some errors. Am I in the right window? Yeah. If compilation fails, we should be like this. So here we should be. Yeah, sure. This seems reasonable. That does seem reasonable what they're doing here. Okay. Var log size is probably use size. Then we call, you know, this stuff with program here, self device, probably cl dot this 0 null log size. Then I guess we just say fuck it. We actually just don't do this, and we just do this instead. We say log is at maximum 1024 characters, and we, I don't know, throw some shit at this thing. So log size here. Then we try to put this in log with null, probably. And then we calculate this at this. Probably. All right. What's going on here then? So this guy is. Can we look at actually what this is supposed to do? This is right. This is right. Param name is build log. Sure. So it returns a char star. Param value size here. Log len seems reasonable here. Then we ask for this and we say, don't give a fuck about the return. Oh, we might, huh? this isn't happening, which is kind of interesting. Wait, nothing's even failing. Oh, I'm a dumbass. I think that we're just chilling, actually. If I throw these back in, he's gonna tell me that it's bad, probably. Yeah, nice. Nice. And then here, it actually ran out of space, so 4096 here. Yeah, nice. Hype. Okay. Okay. So we should be able to. This add extraction is working now. So it looks like this is actually just doing what we want. If we get to the end without any errors. Well, now he's mad again. Because that error is still there. Okay, cool. So now I guess we need to pull the information back off the GPU, right? We need to like look at that output. So I assume we call like the opposite of that write function. Right, we have write buffer here. So I assume we can read the data back. So we have the command queue, the buffer, blah, blah, blah. Okay. So can we just kind of copy paste this to read buffer? We do probably want to put the data somewhere. Okay. Yep. And is the same thing. Queue buffer blocking. Queue buffer blocking. Offset 0 size. Nice. Pointer. Waitlist event. Yep, this is all the same. This is all the same. So at the end of all this, we should be able to be like read buffer event is try executor read buffer with our event pool, and we are reading the outbuff into out CPU. Okay. So this is going to be, I guess, 1,000 F32s. Okay. And this is going to be std_mem bytes or slice as bytes. And then we should be able to just like print that shit. I think. I don't know, maybe. Okay, so that is promising that this data doesn't look like garbage. So we said, what is the function that we're doing? It's a plus a times 2, so a times 3. So 0, 3, 6, 9, 12, 15, 18, 21, 24. I think this is right. I think this is right, baby! So we can change our kernel now. If we wanted to be like, multiply these things, we just change this to be times. And we change our kernel here to be mul. And these numbers got way fucking bigger. So, right, it's like index times 2. So 0 times 0 is this. 1 times 2 is this. 2 times 4 is this. 3 times 6 is this. Yeah, this is right. This is right. Okay. Sick. This feels like a successful API to me. So actually we can also ditch a bunch of these weights, which is kind of sick. So like now all of these guys who ooh, we do have to not return events. Oh, yeah, we do have to not return events if we don't want them, huh? So maybe this should actually be more like like this. Yeah, there's something here where this API needs to be improved for maybe we should have like write buffer and write buffer with event handle or something. Maybe there should just be two different calls. But at the very least, so that won't work correctly. But we don't have to wait in between now, right? We should be able to do this. And we should only have to wait for the thing at the end of the queue, which is kind of hype. We GPUing, it's actually 1 a.m. here. Good night. Good night. Thank you for the help. Yeah, okay. I was hoping we would get to the point where we could like do neural network training with this today, but we are at like a 2-hour, almost on the dot stream right now. So I think that this is a good place to call it. We didn't do a lot. This is a lot of just like OpenGL stuff. But I think we have like some like pretty reasonable APIs now. We have like this like executor that can call kernels. Eventually we're gonna have to like make these kernels. Maybe they become like built in part of the API. I'm not really sure. But yeah, like something we've got something close, right? We have the ability to upload data to the GPU and perform some sort of arbitrary operation on it, which is kind of hype. That's hype. This will allow us to build much more complex behavior. So I think we call it here for today. Thanks for watching, guys. If you like what you saw, we stream most days 12:30 Pacific time to 4 o'clock Pacific time. It is 4:20 now. Blaze it. Bless up. Shut the fuck up. So if you're watching live, you know, anywhere between 4 hours ago and like around now, maybe 20 minutes ago, is like when you should expect to see us live. We're working on this neural network stuff. The next stream will be tomorrow. We should probably spend tomorrow doing like actual integration of GPU training, on the actual like neural network stuff, because we still have like a lot of work to do here, right? We have to figure out like what is the right interface for neural network side of things. How do we track back propagation? How do we store numbers in a way that like can leverage GPU training to do lots of stuff at once? All of that. So we'll be back tomorrow. If you can't keep up live, there's a YouTube link in the Twitch description. Some segment of stuff goes up there, basically things that I think you can kind of like watch without missing anything too important. Stuff that is titleable and thumbnailable goes on the YouTube, but there's a bunch of stuff that doesn't. Like today we were doing a bunch of reading on Vulkan and OpenCL before the YouTube segment started, and that stuff goes in Twitch VODs, on Patreon, or as on YouTube member segments. This gives us something that we can give back to people that want to support the stream, because the stream will stop happening when I run out of money. So if you want to support the stream, please consider supporting on one of those platforms. You get back the rest of the VODs and the knowledge that you are directly contributing to like this stream continuing. But anyways, that's all the plugging we got to do. YouTube, peace out. Twitch, let's find someone to raid.